Hello, this is not your chem tutor, and in this video, I will teach you how to convert molarity to percent mass per volume and the other way around. So from percent mass per volume to molarity. I expect that you already have an idea or you are familiar with the concepts of molarity and percent mass per volume. If in case you are not familiar with these topics, you can check the description box. I put there links to my videos about molarity and percent mass per volume. In this video, I also have two examples. One is for converting molarity to percent mass per volume, and the second one would be from percent mass per volume to molarity. Here are the skills you need to answer some problems. Number 1, calculating the molar mass or molecular weight. Number 2, performing dimensional analysis in converting units. And number 3, mole concept, particularly converting grams to moles or moles to grams. If you are not familiar with some of these topics and techniques, you can check the description box. I put there links to my videos. Let's have a quick recap about molarity and percent mass per volume. Molarity is equal to moles of solute divided by liters of solution. So the unit for molarity is moles per liter, or this is also known as molar, and the symbol is capital M. So for example, you are given 3 molar. This is just equivalent to 3 moles of solute per liter of solution. Okay, let's move on to percent mass per volume. Percent mass per volume is equal to grams of solute divided by ml of solution times 100. You can think of it this way. What does percent mean? Cent means 100, so percent means per 100. So for example, you are given 70% mass over volume. This is just equivalent to 70 grams of solute per 100 ml of solution. Okay? Now, what do you need to convert molarity to percent mass per volume and vice versa? What you need is the molar mass. Molar mass of what? Molar mass of the solute. If you can remember, I told you a while ago that you need to be familiar on how to determine the molar mass of a compound, because sometimes the problems do not provide the molar mass. And if this is the case, you need to compute it on your own so you can carry out the rest of the calculations. Let's start solving actual problems by answering example 1. The concentration of HCl in an aqueous solution is 12 molar. Convert this to percent mass per volume. So our solute is HCl and our solvent is water. When you read the word aqueous, this means the solvent is water. In this problem, we are given the concentration in molar, 12.0 molar, and it is asking us to convert it to percent mass per volume. So how do we do this? Remember what I told you a while ago, that when you say 12 molar, this means 12 moles of solute. Our solute is HCl per liter of solution. So let's just rewrite that. 12 moles of HCl divided by liters of solution. Now look at the formula for percent mass per volume. It says here grams of solute per ml of solution. And what we have is moles of solute per liter of solution. So first, we need to convert moles to grams. So we are given the molar mass of HCl. 1 mole of HCl is equivalent to 36.458 grams of HCl. So moles will cancel, and the unit on top becomes grams of the solute. Next is to convert liters to ml. We know that 1 liter is equivalent to 1,000 ml. So liters will cancel, and the unit on the bottom becomes ml of solution. So we have grams of solute on top, and we have ml of solution on the bottom. And what's missing? Times 100. This one. Times 100. And if you solve this in your calculator, this is equal to approximately 43.7, and just put percent mass per volume. So this is the answer to example 1. Example 2, the concentration of nitric acid in solution is 94.5% mass per volume. What is the molar concentration of the solution? So obviously, nitric acid is our solute. And in the problem, this time we are given percent mass per volume, 94.5% mass per volume, and it is asking us to convert this to molar concentration or molarity. So how do we do that? Remember what I said a while ago? When you have 94.5% mass per volume, percent means per 100. So this means 94.5 grams of solute. Our solute is nitric acid per 100. So per 100 ml of solution. So let's just copy that, 94.5 grams of HNO3 per 100 ml solution. So we have grams on top and ml on the bottom. Now look at the formula for molarity. For molarity, it's moles on top per liters of solution on the bottom. So first, we convert grams to moles. So we are given the molar mass. 1 mole of HNO3 is equivalent to 63.018 grams of HNO3. So grams will cancel, and the unit on top becomes moles. And we know that 1,000 ml is equivalent to 1 liter. So ml of solution will cancel, and the unit on the bottom becomes liter of solution. So on top, we have moles, and on the bottom, we have liter. So moles per liter. And that's exactly the unit for molarity. So the next thing we need to do is to solve this in your calculator. And this is equal to approximately 15 moles per liter or 15.0 molar. So this is the answer to the question.